Okay, in this video I'm going to try to introduce object-oriented programming in Python. And in speaking with some students about how to get started with object-oriented programming, we talked about asteroids a little bit, and I thought, at least for this demonstration, I thought that would be a great starting point. So, and if you're not familiar with asteroids, it's a really early video game that had kind of just a black background with these asteroids drawn on it, and we'd like to create a simple kind of display that looks like that using Pyprocessing and just drawing them using an ellipse shape. But that's where we're going by the end of the video. To get started, we're just going to try to get our heads around some really strange concepts. I think object-oriented programming is hard to understand at first because there's a lot of ideas and concepts and terminology, and it really comes alive when you start using it. And so hopefully you've talked about some of those ideas already, but you might not feel like a lot of these things are making sense, and probably won't make sense through a lot of the video either. You might have to watch it again, or hopefully it makes some sense, but we'll see. But we have to start with a really, and we're going to use a little bit of arrays as well. So I hope you, or lists in Python, I hope you can do a little refresher if you're not familiar with those. So we'll start with the concept of creating an object, and what is an object in the first place? I'm just going to say that an object is like a variable. It's like we want to be able to create an asteroid at some point, somehow, and have it have like some kind of super object powers. That is, instead of it just storing a single value like a regular variable, it can have multiple things about itself that it knows. And then even better than that, it even has things it can do, that it can have methods associated with it, functions associated with it, that it can call, that you can call on it, and that it can do things. So this asteroid this object of an asteroid we're going to create. I mean, if we can create one asteroid object, if we go through the process of kind of telling the computer how to create the one asteroid, then we kind of have if we can create the one, we can create many. We can reuse that code. So in that kind of idea of reuse, we're going to actually create the blueprint for the object first before we actually create it. This blueprint is a kind of definition of something, and we call it a class. And we're used to thinking of objects as belonging to particular classes, and perhaps the reason they belong to a particular class is they were made in a particular way. So this is kind of the code that we're using to make this object, and that in turn we call a class. It's the definition of the object. Now, when I create this object, I want to kind of give it I'm going to give it an X and a Y position. We're going to create an asteroid. We want it to go on the screen somewhere where we want it to go at X 20 and Y 100. So this is kind of where this is kind of the idea. We're going to be able to create this asteroid, and it's going to have these two properties associated with it. Except they're not going to quite look like this. First of all, these properties refer to the actual this is just Python uses this. Other languages use different things. And in Python, when we want to talk about a property of the object itself, we have to say self. So we have to say self.y, self.x, in order to indicate to Python we're talking about your own kind of x position here. It may be using at some point, global variables from elsewhere in the program, or other parameters that were passed in, or whatever, but these properties themselves are particular to the object itself. And the other weird thing we have to do is that we have to put all of this kind of blueprint to create yourself code in a method, a function. This is a function called init, and for initialize. And it's a special one, and we have to use a double underscore at the beginning, at the end, and you just have to do that. And and just for a moment, if you are rusty on creating functions, we use functions to create little bits of code that we associate a name with. So I'm going to create something that adds up two numbers. I call it adder. I use def first. That's the definition for this adder. And I'm going to pass in two numbers, a and b. And then I'm just going to print out their sum. And I do an extra return there, and you can see that I have indented here this code. If I were writing in the editor, I'd do the same thing. And so if I call adder now and pass in two numbers, it prints out the sum. Now, so we're doing the same thing here. We're using def. I have to indent this all to put it underneath this asteroid class because it belongs to this thing. And I use a special one called init. And I have to pass something in, just like I passed in these parameters here. This, inside of this, and in every special function of our object, we have to pass in the object itself. It's just, again, in Python you do this by saying self. Some other languages use other keywords, that some do it automatically, but so this is what we do in Python. So we say self. Okay, so let's just see what this looks like in the interpreter. So I've put my asteroid class into Python, and now I want to create my first asteroid, A1. Not a very good name, but first of all, we give it the class name, and then we call the class using the parenthesis. So this A1. So A1 is like a variable because we used assignment here, and we called the class asteroid using the parenthesis. And so what did that do? That now if we just type in A1, iPython tells us that A1 is an instance of an asteroid. So we've created this thing called an asteroid, and this is an instance of it. And we did that by calling the class name with the parenthesis. So, and then if I press a period and hit a tab, the autocomplete is telling me that there's a bunch of things this A1 has associated with, a bunch of functions that are associated with it, and or properties as well. And so we can see that x and y there. So there's the x coordinate, which was 20, and the y coordinate, which was 100. And we can see them and do stuff using that information now. Okay, so we've created an object, and we've seen that we can do some properties with it. And in order to create it, we have to create a function in this class thing within it. But let's create another one that we're just going to call print or draw. I'll call it draw. Like we're going to find it where it is and draw it on the screen. And what I'll do is I'll print self.x, self.y. So print the x and the y coordinates. So what I'll do is, I'm not sure, can I just drop that in there again? Okay, so then I'll create a new asteroid like I did last time, and I'll check and see it's an asteroid instance, and it's got a draw. It has x and y there just like before, but it also has this thing called draw. And what is draw a1.draw? It's this method of asteroid. This method is a kind of a function that belongs to an object. So you can just think of a method as a function, but it's a function that this special function that only this objects that are asteroid objects have. Well, maybe other ones have it too, but this one is an asteroid one, and we can call it, right? We call it by the brackets. And what does it do? It's printed out 20 and 100, those x and y variables that we assigned as properties. And it used the self.x to print that out. And you see that that came out like that. Okay, so that's, hopefully that looks kind of useful. Let's see how useful this is. And I don't know which thing to do first, but what I think I'll do is I'll just kind of switch over to a list for a moment. So I'm going to create, this is the crazy part of the video, I'm going to create a list called space. And in space I can append, right? So space is, now you know, space is an object. It's an object that belongs to a, a special kind of object in Python called a list, right? And it has lots of great methods associated with them. One's called append, and append lets me add an object to the end of the list. So I can go space dot append or a number or whatever. And so I can add two numbers. The last one I added is the last one on the list. They get added at the end. So let me create an empty list again. And then let me do something 10 times. So I'll use a for loop with the number 10. And each time I'm going to append into space a new asteroid. I just do that. I call asteroid with the brackets. That creates and effectively returns a new object. And then I'm going to dump it into an append, which sticks it into space. And there's 10 instances. Notice that the first thing is a square bracket indicating a list. And if you count those up, there'll be 10 of them. And each one is an asteroid instance. And they're each different. Well, they're all the same because I gave them all the same x and y coordinates. But they actually are 10 different objects that we have. Maybe I should change this. Let's just remember that you can create a random number using random.randint. And if I want to give them a position between, I'm going to create a 600 by 600 screen, I'd use something like that. So that random number, if I can keep doing it right, I get random numbers. So I'll create that for our two. Don't forget I have to import random up here. Random. Okay, so let's just do this again with this version of our asteroid class. And then I have this thing called space, and I'm going to create I'm going to use a for loop 10 times to create 10 asteroid objects, and each of those objects is going to be stuck into a list called space by using append. Okay, so now what does space look like? Oh, well, I forgot. I already had 10 in there. But let's dump them out. So let's do another loop, but let's loop through the list space. So remember, when we use a loop, we have this special variable called the accumulator. In this case, it's the n variable. It gets each value out of the list one at a time. So range 10 produces a list 0, 1, 2, integers from 0 to 9, and 9 and n as it goes through the list is that it's the accumulator. It takes the value of each list item one at a time and works through each one. So what if we were to iterate through our space list and print out the x and the y variable coordinates of each asteroid? I just called it roid for short. So for roid in space, we're going through that list. I think there's 20 of them in there now. The first 10 all have the same position. Then I changed the class. I should have zeroed out the list there, and then the next 10 should have these fancy random positions, the new version of the asteroid class. And there they are. You can see the second bottom half are coming out with those coordinates. Those are those random coordinates I created here. Now, I don't need to do this printing stuff. I just call the draw method I created on the actual asteroid, and it does the printing for me. There's the print statement that I had typed in the first time. Now I'm just calling the actual draw method of each asteroid, and it does the work of drawing them, of printing the coordinates. But we're going to change it. Let's move along, because I think this is almost at the most interesting part. And so let's get some code into this to do this graphically. So from Pyprocessing import star, and let's create a set up in a draw method, set up, and we'll just create a size of 600 by 600, I said. Okay, and I'll just, for draw, I'll just say pass. That's just like a placeholder until I figured out my full method here. And let me do that code I did here. Let me create this global variable called space, a list, and let me use a counted for loop, going through 10 items, 10, doing it 10 times, and I'll append into space each time a new asteroid. Okay, so by the time we get down here to draw, we have 10 asteroids in space, this space list, and we can call the draw method. Now we're not drawing them yet, right? Because we're just printing out their coordinates. Let's just see if this is actually going to be working. I've done this video a few times, sometimes without sound and sometimes without other things. Okay, so we're getting our Pyprocessing screen. We're getting a lot of numbers printing out. It's of course it's trying to draw the screen over and over again, so it's trying to print these numbers out over and over again. And so it's really kind of getting bogged down on that part. So let's change this. Let's change it kind of graphical mode. We said we would do. Actually, let me just do it this way. We said we would draw these as ellipses, so that's fine. They're x and y positions right there. I'll make them 10 by 10. And so just think about this for a moment. We have a list of objects called space. It has 10 asteroid objects in it. And when we kind of kick off this graphical part of the program, every time we go to run the draw loop, we have I'll just, we can put a background, a black space background there. And then what do? We iterate through this list called space, where there's 10 of these asteroid objects, and we call each in turn, we call their draw method. Okay, we're not creating them here, right? We created them up here. We created them up here with this asteroid code. Here we're using them. We stuck them in a list called space. We're using them one at a time. We're calling the draw method. Okay, and there you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I making some? Oh, that one I think I didn't count because it was behind the other window. So I think we have 10 here, all in different positions. Let me run it again, and we'll just see it's going to look different. Okay, because they're in different spots. But we drew 10 of them on the screen. I think this is where object-oriented programming suddenly, and of course arrays, looping through a list of objects, so it suddenly is a very useful thing, isn't it? Like, imagine doing that without some of this code. Like, let me just kind of build on that. Let's just say we have to move these things around. Well, I would just go in here. This is crazy, but I would just go in here and say, okay, well, move asteroid. Before we draw you, move you. And so what's that doing? It's calling a move method. I don't have a move method here, but I just intended to create one. And so there it is. I've created it now, and I'm just going to do a really bad move. I'm just going to move everything 1 over in the x and the y direction. Remember, we want simple things to get started, and then we can fix this later, do something better. But we're just moving it over 1 pixel x, 1 pixel x, 1 pixel y. So it's moving in a diagonal down the screen. Okay, but we added, I think, 4 lines, a call to move, and then a little move method where we move everything by 1 pixel. What's that look like? The whole thing is moving down and to the right. But that's huge. I think it's huge. That's a huge deal. This code is doing a lot all of a sudden, and we just added a few lines. I think you can see suddenly object-oriented programming is something that it works so well for so many things that we model in real life, or we model as games or simulations, and because it allows you to code in terms of that thing that's in the simulation. So now we can just think about coding stuff that asteroids do, and and hopefully that makes our job of and then of course we can use these objects in a list, kind of calling their different methods in turn, and suddenly a lot of things that would get really kind of confusing in terms of too much code and stuff, is nicely organized and nicely nice to look at. So hopefully this helps you get started, um, with thinking about objects and why you might want to use them in Python. And I hope that gets you started with that.